All right, here is your very last notes for the expressions unit. Let's go ahead and fill out our table of contents this very last time. Okay, looking at the learning goals. Today is focusing on learning goal number 26 that says you can write an algebraic expression containing the distributive property to represent situations. So basically, can you look at a word problem or write a word problem and turn it into an expression that is utilizing the distributive property? So learning goal number 26, it's our last one. Go ahead and put your date today, and scrolling all the way down, here we go. So here are your key concepts. Expressions with the distributive property, obviously they have to have parentheses because you're actually needing some number out here to then distribute onto the inside. Okay. On the inside, you must have either addition or subtraction. Okay. And the number outside is being distributed or multiplied to the numbers in the parentheses. Okay. And so that is the important stuff with that. All right, let's move on to the next part. So word problems that can use the distributive property. Okay. These are expressions that can be written with addition or subtraction. So we're either like having a situation where we're joining or taking away. And that particular expression is being repeated multiple times, basically meaning we have that situation 4 times, 5 times, 6 times, so that we can actually be distributing something from the outside. What you want to do is when you're reading these word problems, you want to identify that, focus on the base expression for one, and then on the outside, okay, multiply that by the number of repeats, and that would go out here. Okay, so that's what we're going to focus on today. A little bit of review here with the area model for distributive, but let's go ahead and take a look at this. Find the area for the rectangle below. We know that area equals the length times the width, so keep it simple. Technically, length is the long side and width is the shorter side, but it doesn't really matter. So I'm just going to go ahead and set this up. We know length times width is the one side times the other. So instead of the symbol, I can just put the parentheses and have my 12 plus 8. So I have my length is here, and the width is this distance plus this distance as a total of 12 plus 8. We're repeating that 10 times. Let's go ahead and distribute this out. So the 10 times 12 is our 120, plus the 10 times 8 is the 80, and so inside we end up with 200 inches squared as our area. Okay, all right, let's go to this one. They're saying find the possible dimensions of the rectangle below. So we know what the area is. We need to figure out what could the length and width be. So really, this is a factor problem. We were wondering what numbers could be multiplied together to make 56. And so when we're looking at this one, we can be sort of setting up our little factor rainbow here. I know 1 and 56 is an option. I know that 2 and 28 is an option. And if I didn't, I could do 56 divided by 2. 3 doesn't work. I can do that division. 4 does work. We have 4 and 14. And then that is going to be it with that. Okay. And then we have 7 times 8 is 56. And that's all the way to our center. All right. So those are all of our options. And so the possible dimensions, I could have a 1 by 56. I can pick anything that I want to do with that. So for example, I could have a 1 by 56. I could have a 2 by 28. I could have the 4 by 14, and I could have the 7 by 8. Okay, and so if we want, we could even separate it out like the other problem, but we technically don't need to. So I'll just do 7 times 8 because that's easy. So we'll say the 7 is here, and we'll say the 8 is the 4 plus the 4. Okay, and so our length. So I could write something like that if I wanted, or keep it uncomplicated and just write that my width is 7 and my length is 8 and call it a day. Okay, so lots of options. All right, let's go ahead and look at the word problems. There's 29 teams in the NBA. Each team, so each typically means multiply. Okay, it can, not always, but a lot of times. Each team can have a maximum of 12 healthy players. Notice plus 3 players on the injured reserve. Okay, use the distribute property to find the maximum number of players who can be in the NBA. So remember, our tricks with this is thinking, okay, so first of all, I do notice some operation hints here, each and plus. I want to think on one team, what is my option expression-wise? So on one team, I can have 12 healthy players plus 3 players on the injured list. So I'm going to put that in parentheses because that's one team. There's not one team, there's 29 teams. So I would multiply that situation by 29. This is how I would set up an expression that is written using the distributed property. Okay, and then I can actually go ahead and I could distribute these out to figure out what the maximum number of players could be in the entire NBA. So it doesn't say write an expression. It actually says use the distributed property to find it. So we do need to go ahead and solve this out. So I'm going to grab the calculator here and do the 29 times 12. So we have 348 plus 29 times 3 is 87. We can join those together now, and we get a total of 435 players could be in the entire NBA. Okay. All right, let's look at our next situations here. Write an algebraic expression with parentheses to represent each situation. Simplify as much as we can for that as well. All right, so first we're just representing the area. So this is a length times width situation. I have 4 times 2x plus 9. Okay, and then this would then be written as an area. And so I could write it just like that. Okay, or I could distribute it as well, because remember, simplifying means getting rid of parentheses. So I am going to have to do that for this one. So I end up with 8x plus 4 times 9 is 36. And this goes up here. So the area equals 8x plus 36 inches squared. Okay. All right. So that is the area. Now let's go over to here, find the possible dimension. So same as we did above. If you want to try this out and then see what I do, you can do that. So our area equals 14x plus 28. It's a little bit different, I guess, because we have the 14x and the 28 centimeters. So we're just going to have to factor out a length and a width. So when I look at this, I'm going to rewrite this here. All right, so we want to go ahead and pretend that this is just a factoring problem. So let's go ahead and factor out different things. Because I have to list a whole bunch of possible dimensions, I'm actually going to start with the least common factor rather than the greatest. And so I'm just going to factor out a 2. I know that 2 times 7x is that, and then 2 times 14 is the 28. So that's one length times width combination, or width times length combination. I know that I can factor out even more from that. So I can factor out a 7 from there as well. And so let's see. If I factor out a 7, we could do, let's see. I'm actually going to just from the original factor out the 7. So 7 times 2x is the 14, plus 7 times 4 is the 28. So that's another length times width option. And then if I'm able to pull out a 2 and a 7, that means I'm also able to pull out a 14 or factor out a 14. So I'm going to factor out the 14, which would be with x plus 2. Okay, so those are all my possible dimensions for the rectangle below. I guess technically I can always factor out and have a length of 1 and a width of 14x plus 28. But that's a little bit lame of an answer choice. All right, anyway, next word problem. There's 29 teams in the NBA. Each team can have a maximum number of X healthy players. So we just have a variable plus 2 players on the injured. Again, each usually means multiply. So focus on, it says using the distributive property, write an expression. So we're not going to be able to actually evaluate this one. So let's go ahead and write our expression for one team. So one team is X healthy players plus 2 players on the injured. So this is one team. So what would 29 teams be? It would be this. I'm going to distribute it to simplify, which would simplify to 29x plus 2 times 29 is 58. Okay. All right, so we're done with that one. Now we go to this word problem. So 3 days a week. Okay, so this only happens, so a whole week is just the 3 days. Mrs. Naku does a swim workout. Each day, that's multiplying, she swims. She does a warm-up that is this long. She also does this main set that's this, and a cool down that is this. So that's the thing that happens on one day. Using distributive property to write an expression to represent the number of yards she does in a week. And a week is, for her, not 7 days, but only 3 days. So that's something to be aware of. All right, so we're just going to do, what does she do in one day? In one day, she does a W plus an M plus a C. That's one day. In a whole week, she does that and repeats it 3 times. So to simplify this, I'm going to distribute the 3 out, and we end up with 3W plus 3M plus 3C as the expression. All right, Ryan, who's 4 years old, and Ben, who's 8 years old, are brothers. Okay, don't care at this point. Their dad's weight goal is to weigh double the sum of their weight. So sum is addition of their weight. So I need to find out what their weight is. The dad wants to do 2 times or double. Okay, so that's something to sort of be aware of here. Okay, write an expression to represent the dad's goal if Ryan weighs this much and Ben weighs this much. So what is the sum of their weight? What's the single thing? It's 25 is Ryan plus B. Okay, so that's the weight of the boys. The dad's goal is to weigh double that. Okay, so double means times 2, so I'm going to put that on the outside, and so this would represent what his goal is. Okay, now that I have the distributive, I can go ahead and distribute that so that it's simplified. So 2 times 25 is 50 plus the 2B. Okay, and that is how many pounds dad's goal is. Okay, so those are your word problems and a little bit of distributive property review with a little twist there. Okay, great job.